Let's look at the properties of integer exponents. For n and m integers and a and b real numbers, we have the following properties. The first property states that a to the n times a to the m is equal to a to the n plus m, and is often referred to as the product rule. For example, a squared times a cubed is equal to a to the 2 plus 3, or a to the 5th. The second property states that a to the n raised to the mth power is equal to a to the n times m, and is often referred to as the power of a power rule. For example, a squared cubed is equal to a to the 2 times 3, or a to the 6th. Notice that in the first property, when the base is the same, we add the exponents, whereas in the second property, when you have a power of a power, we multiply the exponents. These properties are often confused, so know when to add and when to multiply. The third property states that a times b to the mth power is equal to a to the m times b to the m, and is often referred to as the power of a product rule. For example, a times b squared is equal to a squared times b squared. We raise both factors to the power of 2. The fourth property states that a divided by b raised to the mth power is equal to a to the m divided by b to the m, and is often referred to as the power of a quotient rule. For example, a divided by b raised to the third power is equal to a to the third divided by b to the third. And here we're assuming, of course, that b is not equal to 0. All right, the fifth property states that a to the m divided by a to the n is equal to a to the m minus n, and is often referred to as the quotient rule. For example, a to the 5th divided by a squared is equal to a to the 5 minus 2, or a cubed. So when the bases are the same and we're dividing, we subtract the exponents. The sixth property states that a to the 0 is equal to 1 for a not equal to 0. 0 to the 0 is not defined for various reasons, and this is often referred to as the zero exponent rule. For example, 3 raised to the 0 power is equal to 1. And the last property to consider here is that a to the negative nth power is equal to 1 divided by a to the positive nth power, and is often referred to as the negative exponent rule. For example, a to the negative third power is equal to 1 divided by a to the third power. All right, let's see an example. Let's simplify the following expression and write our answer using only positive exponents. Since multiplication is both commutative and associative, we can regroup this multiplication as follows. We can take all the numbers first, the 2, the 3, and the 5, and multiply them. So this is equal to 2 times 3 times 5. And then multiply the w terms together. So times w to the negative 5th power times w to the 4th. And then group the v terms together. We have this term and this term. So times v to the negative 6th power times v to the 7th. And finally, we'll group the u terms together. So times u to the 7th times u squared. So this is equal to 2 times 3 times 5 is 30, and then times w to the negative 5 plus 4 by the product rule. Because these bases are the same, we can add those exponents. Same with the v terms, so it'll be v to the negative 6 plus 7. And finally, we'll do the same with the u terms, so it's u to the 7 plus 2, which is equal to 30 times w to the negative first power times v to the positive first power times u to the ninth. And then by the negative exponent rule, this is equal to 30 times 1 divided by w to the first power. Remember, we want to write our answer using only positive exponents. And when the exponent of a variable is 1, we usually do not write it. So writing this as one fraction and dropping those exponents of 1 gives us our answer of 30v u to the ninth divided by w. All right, let's see another example. Let's simplify this expression and write our answer using only positive exponents. Well, the first thing we can do is simplify what's inside these parentheses by, again, grouping like terms. So this is equal to, let's group our numbers together, so 6 divided by 3, and then times, grouping our m terms together, we have m divided by m to the negative 1. And then finally, grouping the n terms together, we have n to the negative 2 divided by n squared, still raised to the negative third power, which is equal to 6 divided by 3 is 2, and then times m raised to the 1 minus a minus 1. And this comes from the quotient rule. Because the bases are the same, we subtract the exponents. And we'll do the same with the n terms, so it's n to the negative 2 minus 2. Whole thing still raised to the negative third power. And this is equal to 2m squared, because it's 1 minus a minus 1, times n to the negative fourth power, whole thing to the negative third. And then by the power of a product rule, we can raise each of the factors to the negative third power. Which is equal to 1 divided by 2 to the positive third power by our negative exponent rule. And then times, we have a power of a power, so remember we multiply 2 times negative 3, which is negative 6. Same with the n term. We have a power of a power, so we multiply. So we have negative 4 times negative 3, which is positive 12. And remember, we want to write our answer using only positive exponents. So let's use that negative exponent rule again on this m term. So this is equal to, we have 1 over 2 cubed is 8, and then we have 1 divided by m to the positive 6th power, n to the 12th. And writing it as one fraction will give us our answer of n to the 12th divided by 8 times m to the 6th. And this is how we work with integer exponents. Thank you, and we'll see you next time.